This question is about describing the motion of a car and also stopping a car. So we have a car has an oil leak. So that means oil will be dripping out. Every 5 seconds, an oil drop falls from the bottom of the car onto the road. What force causes the oil drop to fall towards the road? So it's falling down towards the road on its way towards the centre of the earth. So that's gravity or weight. Okay, you must not put gravitational potential because that is a type of energy and it's asking for a force. Forces and energy are not the same. So gravity or weight. The diagram shows the spacing of the oil drops left on the road during part of a journey. So it's going from A to B. Describe the motion. So thinking about motion, your keywords there are things like stationary, which means not moving, velocity, speed and direction, so constant speed, constant velocity, its speed isn't changing, and accelerating, which means speed up, or decelerating, which means slowing down. Okay, so describe the motion, describe the movement. We're looking for one of those sort of 4 keywords: stationary, constant velocity, accelerating, or decelerating. So the thing we can notice is that the dots start off at A being close together and they get further apart. Okay, because it's every 5 seconds in the same amount of time, that means between each dot or drop in the same amount of time, it's travelling a greater distance. So the speed is actually increasing. So over here, it's travelled a greater distance in 5 seconds, so it's gone faster than in the 5 seconds at the start. So our key word there is that it is accelerating because the speed is increasing. If you put speed or velocity is increasing, you'd still get the mark. Explain the reason. You're going to get 1 mark for saying the distance between the drops increases, and your second mark is for saying that there's the same time between the drops, or even just highlighting the fact the drops fall every 5 seconds. You could say the drops fall at the same rate instead. So we're now moving on to talking about stopping our car. So when the brakes are applied, a braking force slows down and stops the car. The size of the braking force affects the braking distance of the car. State one other factor that affects the braking distance of the car. So a factor is just something you change that would change the braking distance. So one other factor, so you can't put braking force again because they've told you that. So that would be things like the weather, if it's wet or icy, or things like the brakes, the road surface, or the tyres. Sometimes people try and talk about the mass or the weight of the car, but because we're talking about a specific car, that's not relevant here. The other one is the speed the car's going at. Then part 2, a braking force of 3 kilonewtons is used to slow down and stop the car in a distance of 25 metres. So just think to yourself, are those standard units? Are there any we need to convert? Metres is a standard unit, so we don't need to convert that. Kilonewtons is not a standard unit. The standard unit is newtons. So because it's kilonewtons, we need to change that. We need to times it by 1,000 to get that that's the same as 3,000 newtons, which is now in a standard unit. Calculate the work done by the brakes to stop the car and give the units. We mustn't forget that. So we look at the equation sheet. There's several equations involving work done, but we're looking for one that's including force and distance. So we come up with work done equals force times distance. We're calculating work done, which is on its own on one side of the equals, so we're not going to need to rearrange. So we just write down, we substitute in the numbers. Work done is force is 3,000 times by distance is 25. Okay, so that's nice and straightforward to type into a calculator. You come up with 75,000 forgot my equal sign. Again, it is easy to type things into a calculator incorrectly under the stress of an exam, so I would recommend typing it in twice, and particularly if you're finished at the end and you've got some spare time, I would be going back and typing all the calculation questions into my calculator again to double check. Give the unit, work done. The phrase means energy transferred, so it's measured in joules, just like energy. So you could either write the word joules or you could write a capital J to stand for joules. I just almost missed off a 0. That's a common way people lose marks, is they don't write down all the zeros. So that's another thing to be checking for at the end of the exam if you've got spare time.